So serverless application framework. Assuming my Mac lets me continue. You would tend to think that, like, what is serverless? Does that mean that they're servers? What does that mean that you're just running locally? So contrary to popular belief, but serverless is a term for running things on servers that you don't actually manage. So instead of running something on Flash or on the EC2 or on physical hardware or on Kubernetes, you're running a function as a service. So you have a specific function. You don't deal with auto scaling, and you don't, well, you can provision auto scaling, but you really it's hands off. You have your code, and you have some sort of event source that executes it, and then the code runs. So let me go to the next slide. This goes back to what I was saying before. You only pay for what you need, and one of the big advantages of having serverless is that it's very, very economical. So if you compared hosting a service in the cloud on EC2 or Fargate or some other container service where you actually have to manage a Flash server, you're going to be paying probably per hour or at very least per second, and you can't turn your server off and on, right? If you have your code running, for the most part, it's always on. You can have auto scaling group, but you're going to have at least some capacity up unless your website or your service only runs for like 3 hours a day, and then you turn it off and then turn it back on. For most of the day, even though you might not have as many function calls, you're still paying for it 24/7 for the most part. Where function as a service, you pay only for the execution time, and this can add tremendous cost savings. So instead of spending $1,000 a month on servers, which are mostly idle but get a few requests per hour, you pay only for a few seconds where your functions are running. So instead of paying $1,000, you're paying $20. A magnitude, a huge difference. So before there was serverless, people used VMs, virtual machines, and they would divide a physical hard drive with multiple operating systems. And then there was containers and container orchestration, which most people are using now. Most people are using Docker or Podman, and they're using something like Kubernetes or OpenShift to orchestrate the containers. But serverless is sort of a next evolution. I wouldn't say it's a replacement for containers, because there's certain things that you can't put in the serverless function, but it's more economical. It's easier to manage. You don't really have to worry about auto scaling, because it executes when you need your code to run. And by far, I mean, you're definitely saving. For most cases, you're saving money. Not always. Like if you have 1,000 requests every hour and you're using every request and you're not going over, there might be a case where a container or a virtual machine would be more economical. Probably one of the most popular serverless functions or services is AWS Lambda. So serverless is generic across all the clouds, major cloud providers. So it runs in Google Cloud, it runs in Azure. I think there's the serverless framework also works in IBM Cloud, and I wouldn't be surprised if Alibaba also had serverless framework, but I'm going to primarily focus on AWS because it's the biggest cloud provider and it's what I know most. But all the major cloud providers have very, very similar services. They just have slightly different names. So AWS Lambda is where you run your function as a service. It can run to up, it's Lambda, but it's not Python Lambda. It is a function, but it's not, writing a anonymous function. This is a AWS service. It auto scales horizontally as much as you want, but you can, if you want to set, the Lambda function that only one can run at a time, you can, but that's an additional setting. You can have your Lambda function run up to 15 minutes. if you want, but by default runs um, a lot quicker. It usually times out after 5 seconds by default, but you can have a Lambda function run up to 15 minutes. It can run within a VPC or a virtual private cloud, or you can, so if you want to run a function and hit internal endpoints and not be exposed to the internet, you can do that. There are multiple event sources. So if you want to run on a cron job or run from another Lambda function being innovated, or a step function, or an S3 event, there's a lot of different ways to call Lambda. And it takes 2 positional arguments. These are optional. The first one is event. Event is basically a JSON object that you handle to the Lambda function. And this can be pretty much whatever you want it. These are just inputs to your function. And then there's context. And context is more metadata about the function, like what was the function's name if you didn't know the function's name, or the runtime, or some other metadata about the Lambda function that you want to grab. It supports a variety of languages, but because this is a Python meetup, I'm mostly just going to focus on Python. And there's also storage, and this actually doesn't clear out all the time. You have to clear out yourself, but you can put files into the Lambda function. So if you have a flat file or an image file and you want to grab it from S3 or some other storage, you can put it into your Lambda function and hold on to it and perform some analysis, transform it before moving it out. So historically, before the serverless framework, there was another way you could deploy serverless applications. This is specific to AWS, but again, all the cloud providers had ways of deploying serverless applications, but they were all pretty messy. So in AWS, you used something called SAM, which is Serverless Application Model. There was a command line interface. You would write CloudFormation code, and you would write a lot of boilerplate code. You would write a lot of code that did something relatively simple, and it would all be YAML. It'd be a long CloudFormation templates, like 500 to 600 lines. And usually once the Lambda function got above a certain size, you would have to upload it to S3, zip it up, and trying to get Python dependencies or pip dependencies was a little bit of a nightmare. There was stuff that was part of a native operating system, but just wasn't in Lambda, and trying to port it and move binaries. It was a mess. You can still do it this way, but I don't recommend it. I have done it this way, but I'm going to use the serverless framework every time I can when I need to write a Lambda function, because I don't recommend using SAM or a previous way of deploying Lambda functions. Serverless application framework is multi-cloud, so it works on AWS, it works with Azure, it works with GCP, and it works with several other cloud providers. It's open source. They do have a paid plan for support, but I mean, it's open source. You don't really need that. It's a Node.js library and has a command line interface, and you configure everything with a YAML file called serverless.yaml. And there's a variety of open source plugins. And probably the best thing about the serverless application framework is it removes most of the boilerplate code. When you're writing raw CloudFormation with SAM, you would probably write what you would write in 700, 800 lines of YAML, you can do in about 10 lines with the serverless application framework. So you get the same functionality, but with a lot less code, with a few plugins, and you get a command line interface for testing locally, which is more intuitive than the native AWS tools or other cloud providers. There's a lot of different things that integrate with the serverless application framework. So of course there's Lambda, which I discussed earlier. You can also integrate S3, DynamoDB, SQS, and technically you can put any CloudFormation resource into a serverless.yaml file. So if you want to put, I don't know, Kubernetes in there, or EC2, a relational database, you can technically put it in there. I wouldn't recommend it because this is meant for serverless applications, but you can put non-serverless resources in a serverless file. You deploy it the same way. It works pretty similar across other cloud providers, but again, I'm mostly focusing on AWS for this talk. These are some common commands you're probably going to want to use for a serverless application framework. The first one is SLS deploy, and then you do -s for your stage name. So a stage name, you might do staging or development. And this is like a prefix that gets moved to all of your functions and resources and S3 buckets. It's a way to identify if you're doing blue-green deployment, you could have a different stage name for deployment. So maybe if you have a development 1 stage and then you have a development 2, you would give them each a different stage, and then you would use the DNS to allocate traffic to either of the stages or do some sort of canary deployment. The other command I want to show you is the SLS invoke local, and this lets you execute the Lambda function locally, and you can also assign it data. So in your event function or event handler in your Lambda function, you can assign data into the CLI argument, and so you can test and debug locally. And then there's also SLS -h or help, and then there's SLS remove -s and to remove your stage. There's about 30 more commands than this, but these are the commands you probably need most. These are the only commands you really need. There are more commands, but these are commands you're going to be using most often. There's a lot of event sources for AWS Lambda. You can do S3 events. So if somebody uploads a file to S3 with a certain prefix, like maybe you only want PDFs to get uploaded to S3, or maybe you only want when you upload an HTML document to S3, you can take that as an event source, and then the event handler and the AWS Lambda function will trigger. You can parse the data, put it into a TMP directory, and then move it somewhere else. There's also a service called API Gateway, and you can use AWS Cognito. And you can do this all within serverless framework. You provision Cognito with CloudFormation, provision API Gateway, and then you can have a static website with Cognito, and it can authenticate to API Gateway and is protected with Cognito access keys, which are generated when they log in. So you can have a static website in WordPress or S3 or some other cloud provider. You don't need a backend. You can connect directly to API Gateway and then trigger Lambda functions. You can also trigger Lambda functions based off cron jobs on a certain schedule. Maybe you want to trigger every half hour, once every 5 days, odd times. Step functions are like for workflows or a sequence of Lambda functions. They don't have to be Lambda functions, but a sequence of events. And then you could trigger 2 Lambda functions, and then I don't know, you call a queue, an SQS queue or SNS queue. And then there's also CloudWatch events. And so any CloudWatch event in AWS, you can also call, you can trigger a Lambda function off any of these. So if something happens in AWS, like your database becomes unhealthy, you can trigger a Lambda function, and you can set it up with the serverless framework. I won't go into too much detail with some other CloudWatch events because that's probably higher level than this talk needs, but there's a lot of other triggers that you can use to trigger a Lambda function. So it's in a YAML file, and so over here you can see the plugins. These are some popular plugins you probably want for Python with the serverless application framework. The bottom one is IAM roles per function. Again, these are open source. Pseudo parameters, so you can set the stage. Python requirements, so this lets you bundle all your pip requirements.txt files. So pandas, NumPy, it lets you bundle all of those up. You can also deploy directly to S3. You can have as many of these plugins as you need. You use Node Package Manager to install them. So you just do npm install, the name of a plugin, and then you put it at the top of plugins. Here we're specifying Python 3.7. And this is the Python requirements, which is shown here. And we can actually Dockerize pip if we wanted to. So when we upload our requirements.txt, all those dependencies, if we have Docker running, we can download everything in Docker and then upload Docker. And that will help with dealing with pip dependencies. There's a bunch of different options. I'm not including a part of a file where you actually have the functions, but it's pretty intuitive. There's plenty of tutorials on the serverless application framework website if anyone has any questions. Any other questions? I know I went really quickly and this was a lot of information. Benjamin, I see you raised your hand.
Hey, great talk. Can you see me? I hope you can hear me fine. So I've used AWS Lambda for the last almost 2 years in a lot of the same ways that you're talking about with Python, running batch, cron job, event-driven. My two questions are, I've never used the SLS framework. I've always just kind of packaged up dependencies that weren't initially in the Lambda environment in a layer, as well as codependencies. So my actual question is twofold. The more important question, I think, is with your SLS framework, how do you, let's say we have a library, like an internal library of tools that we use, a utilities tool that we use amongst a bunch of different Python scripts, right? A bunch of different Lambda functions. How would you do that in the SLS framework where you're like, hey, I have this internal utilities file I need to distribute to all of my functions?
Well, I would assume you would just download it with a module. You would download the module. There's a configuration in some of the plugins where you can change the pip repository. Something what you could also do is you could use AWS Artifact or some artifact management like Artifactory or our sponsor, or Code Artifact on like AWS or one of the many other artifact repositories. You could use that as a private pip repo. Upload your private pip repo along with all your public pip repositories, and then when you're about to download the repositories for serverless application framework, you set it to that private pip repo and you download everything locally then.
Okay, that makes sense. And then my other question was, do you see a lot of value added? Because I found that, doing it with layers at the scale and the complexity that I'm at doesn't seem like to be that interruptive. Do you see any other reasons from either a DevOps or from a software management? Is it easier to control versioning? Do you have any reasons why some company would want to say, okay, we want to transfer it from doing, I have these Lambdas that we attach the layers that we need for the external tools to something like a serverless framework? And thank you.
From a DevOps perspective, just being able to have everything in code and being able to manage all your dependencies and deploy to multiple environments and know that your artifacts are going to be reproducible in any environment you deploy to, it's very helpful. Like my current company, our customers are single tenant, so every one of our customers has their own environment. And so if we try to set up Lambda layers and try to make them share, and then there's a lot of stuff that you would have to do in the AWS console and downloading dependencies and trying to replicate that. And with the serverless application framework, we can essentially, with a command line interface, if we write scripts, we have something reproducible that we can put in any environment. I've used both SAM and I've used the serverless application framework, and I wish I used serverless application framework first. It just something that took 2 weeks using SAM took about 30 minutes using the serverless application framework. It's just, there's a lot less boiler code. All your infrastructure is code, and there's just less configuration. Peter, I see your hands up.
Hey, good evening, everyone. Hey, host Fisher, how many talks do we have tonight? I tend to ask long questions.
We have 3, but yeah, I guess try to keep it a little short, because I try to do only like 2 minutes of questions per speaker.
Sure.
Like if it's really long, feel free to,
Sure.
ping Keegan after.
Sure, I'll make it short. So in layman's terms, with serverless, like the AWS Lambda model, let's say you have an HTML file that just says hello world, and someone's coming in on port 80. Is this kind of like a single command line is getting launched once this stage is hit? Is the stage like the nickname?
So if you have the HTML file, that wouldn't directly be a serverless function. That wouldn't be a Lambda function or Google Cloud function. That would probably be a static, somewhere where a static website was being hosted. So that would be, like S3 or GoDaddy, or it would be somewhere where you'd host a static website. But this allows you to do, like you can trigger Lambda functions from REST calls, and the stage is to specify the version. So, or it's like in more of a naming convention. So you're like, oh, okay, this is our development stage. Let's deploy another Lambda function, but we'll call it staging, and it's in the same account. So the stage is more for naming and tagging, but Lambda functions, it's just a function as code, but you can't get just put a raw HTML file. But if you want to do like a REST call, like let's say you had some JavaScript and then you call API gateway, which allows you to call a Lambda function, you could do it that way. So you could have a static website which does backend calls.
So Lambda is not an alternative to, what's that called? Node.js, where you're kind of spraying a page out at the visitor?
Well, you can do Node.js. So a Lambda function can have Node.js code, but you wouldn't have Express. So like an Express server, or a better way of framing it is that instead of using Django, or instead of using Flask or Express, you still have Python, you still have Node.js, but it's just all your functions are Lambda functions. So if you want to get all your users, you call the endpoint in AWS, and that just calls one Lambda function. So instead of paying for a server as 50 functions, you're just paying for each function as time goes on. And you're probably not going to call all the functions all the time, so you should save money.
Cool, thank you.
I saw there was one more question. Looks like the hand is down. Oh, Maria.
I just asked it in the chat to save time.
Oh. Okay. Let me.
It was about like if you ever moved between clouds, was the framework, and how difficult it is to move from, I don't know, AWS to GCP or something.
So you definitely can move cloud providers. However, Lambda functions and their syntax and the SDKs are specific per cloud. And if you're like, when I write serverless files, I usually use a lot of CloudFormation, and CloudFormation is not going to work in Google Cloud. It's not going to work in Azure. So you can definitely use the same command line interface, but as soon as you change providers, all your plugins are going to break. Your event and context handlers, there's a lot of things that will change. So I wouldn't, you could run them in parallel, but there'd be a substantial amount of code that would need to be rewritten. It'd be like using, like Terraform is technically multi-cloud, but if you're writing all your code for AWS and you want to go to Google Cloud, you have to write a lot more Terraform. You can deploy both using the same interface, but it's still a lot of work.
Thanks.
Oh.
Last call for questions.
Peter.
Oh, hi. As we know, my question is, we know that the serverless framework is written in JavaScript, Node.js, as you know. And we know there are many alternatives. Even AWS have official Python serverless framework. So my question is, why you choose to use the serverless framework with Python and not others?
Well, there are alternatives. I mean, I think it's been around a little bit longer than some better alternatives. Like I know AWS came up with, I can't read, I think it's Chalice. It's a Python.
Yeah, Charles.
Yeah. But you don't have a amount of plugins. You don't have quite the level of support. And for serverless applications and trying to manage dependencies, the serverless framework, I think, is a better choice. And like where I currently work, we don't just do Python, we also do JavaScript. And so having one framework that does both, we can deploy JavaScript, we can deploy Python, we can deploy Golang. Having one framework where we can deploy any of these is pretty useful. I mean, we're at a Python meetup. I think almost everyone here's favorite language is Python, but having the option to deploy multiple languages is a huge plus. And the native integration with CloudFormation, at least on AWS, is very useful.
Okay, thank you.